So we're looking at 5.8. All right, so for the first one, like I said, we're just looking at applications of trig functions. Tell us to solve the right triangle. So we're going to find all the missing pieces. So what we do not have, well, what they give us is 34.5 degrees for capital A. And we see that 90 degrees is for C. So angle B, we don't know off the top. Then they give us side B, which is 10.5. So side A and side C is what we don't know. All right. So we can find B. How? Yeah, I guess I'm gonna do that. Oh, let's do it like this. So the sum of the angles in a triangle is 180 degrees. So we can find B by taking 180 degrees, or well, we could have did 90 from there anyway. But and it was 180 degrees minus A and minus C. So that'd be 55.5 degrees. Any problems with angle B? All right. So we can can find side A. Notice we have our angle A that was given to us. And we have side B, which is adjacent to angle A. And we want to know the opposite side, so we can use the tan relationship. Let's equal the opposite over adjacent. So opposite is A. So you have tan of 34.5 degrees equal to A over 10.5. All right, then to solve, multiply both sides by 10.5. So A is going to be equal to 10.5. Let me make myself more room. When you throw this in the calculator, make sure your calculator is set for degrees, not radians. And that would be approximately 7.22. All right. And last one, side C. Since we have a right triangle, we could use Pythagorean theorem. But I'll go ahead and keep with our trig relationships. Nothing wrong with continually to emphasize that. So we have cosine A. A is our angle. And we want to use, and we might as well use the given, which is 34.5, the adjacent side, and the hypotenuse, because we want to know what C is. So we'll do cosine adjacent over hypotenuse. So that's why I went with cosine. The reason you do that, because if you miscalculate it on that 7.22, at least you don't get both of them wrong. So normally you stick with the given. So got cosine of 34.5 degrees equal to 10.5 over C. Now if I want to solve, I'm going to multiply both sides by C to get C out of your denominator. So now that's C cosine 34.5 degrees equal to 10.5. Now divide by cosine of 34.5 degrees. So now we have 10.5 over cosine of 34.5 degrees, and that will be approximately 12.74. All right, questions.
Nothing here.
All right, sounds good. And always make sure you go back, check your answers. If that is your hypotenuse, it should be your largest side. Each one of your lengths of your sides should correspond to the measure of your angles. So the shortest side is A. That means the smallest angle should be capital A. And you know the largest angle is going to be 90 degrees. That's why your longest side is the 12.74. So all that should match up. All right. So let's look at another one. All right, so from a point on level ground, 120 feet from the base of a tower, the angle of elevation is 57.2 degrees. Approximate the height of the tower to the nearest foot. So got a little bit of a diagram here. Let me see if I can do that. All right, so that's the diagram. So we have 57.2 degrees angle of elevation. Put a little arrow, but it's coming from the ground up. That's your line of sight. And 125 feet from a point on level ground. So that's what we got there. And we want to know what is the height of the tower. So that's what A is. That's the opposite of your 57.2 degrees. So what we can use here is tangent. Tangent of an angle is equal to opposite over adjacent. So we got the tangent of 57.2 degrees is equal to A over the 125. All right, so now solve for A by multiplying both sides by 125. A is equal to 125, tangent 57.2 degrees. And they told us to round this to the nearest foot, so that would be approximately 194. So tower is 194 feet tall or high. All right, so a kite flies at a height of 30 feet when 65 feet of string is out. If the string is in a straight line, find the angle that it makes with the ground, round to the nearest tenth. All right, so this is the little diagram we got. We have a kite that flies at a height of 30 feet when 65 feet of string is out. So that's my diagram. The blue line is the string. And then over there, A is 30 feet. That's the height of the kite. So we want to know, find the angle. We want to know what the angle is that it makes with the ground. All right, that's the drawing I got. So let's go ahead and calculate. So if we were to go off of this diagram, we want to know what the angle is. We'll be using sine, because that is opposite over hypotenuse. So we're looking at sine of A. We don't know what A is, but opposite is 30. Hypotenuse is 65. All right, so don't forget you do have sine inverse as an option to get sine off of A. So applying the sine inverse to both sides, you'll be left with A is equal to sine inverse of 30 over 65. And that is approximately 27.5 degrees. All right, any questions before we look at another one? So this section is just word problems, different types of word problems. Probably do about 2 more and probably be good. And then we'll talk about how we're going to close out this chapter. I'll draw the diagram in a second, but I'll give you a chance to write. It says you are taking a balloon ride. Your friend is standing on level ground 100 feet away from your point of launch. Actually, had more sentences than this. It was talking about how your friend is watching you with video cameras, videotaping your response and how terrified you look and all this stuff. So I just didn't write all that, but that's why the friend is over there. So 100 feet away from your launch, point of launch. At one instant, the angle of elevation from your friend is 31.7 degrees. 1 minute later, the angle of elevation is 76.2 degrees. How far did you travel during that minute? Always make sure you pay attention to my math lab, what they want from you in this problem. It actually mentions they want us to round to the nearest tenth. They should tell you something, either round to the nearest tenth, round to the nearest degree, that type of thing. This one mentions rounding to the nearest tenth. All right, let me see if I can draw this. We'll do that better. All right. Oh, that's not good. All right, that's good enough. All right, so we have these two triangles working for us. We have the height of the balloon in the first. Let's see, it's at one instant. So at one instant, we have the height of the balloon at a certain height, and then 1 minute later from that instant, it goes to another height. So it's asking us how far did the balloon travel within that minute. So we need to find A, and then we need to find B, and then subtract them from each other to see how much distance was covered from point A to point B, or height A to height B. Okay, so it looks that we will be using tangent, if I can get my stuff right. Yeah. So you're talking about tan is going to be opposite over, yep, I forgot my height down. Not my height, but my distance from the friend to the balloon is 100 feet. All right, so tangent, we're going to use the opposite side, and on bottom we'll use the adjacent side, so it's opposite over adjacent. All right, so we're looking at the shorter height of the balloon, looking at 3110 of 31.7 degrees, and that's equal to A over 100. So we multiply both sides by 100. A is going to be equal to 100 tan 31.7 degrees. That would be approximately, and it's not degrees, keep doing it. That would be approximately 61.8. That should be feet, up in feet. So a taller height, same relationship. We'll do tan of 71.2 degrees though. B is still over 100. So that'll be 100 times tan 71.2 degrees. That'll multiply each side by 100. And that'll be approximately 407.1. So now to calculate the distance the balloon traveled in that minute, we would do 407.1 minus 61.8, and that would be 3,000, whoa, 300, I mean, 45.3 feet. All right. Questions.
Nothing.
All right, sounds good. All right, trying to find me another good one. Give me 1 second. Okay, let's try this one. All right, so I'll show you some examples of how we use it in a second, just in case you're not nautical like me. Some of you may already have experience using this, but your bearings. In navigation and surveying problems, the term bearings is used to specify the location of one point relative to another. The bearing from point O to point P is the acute angle. And I think that should be pointed out as the acute angle, measured in degrees between ray OP and the north-south line. All right, so first one, bearing from OP, from O to P is north 40 degrees east. I guess that's how you say it, unless it's northeast 40 degrees. Somebody can always correct me. I'm not that guy, but I do my best. So it's either north 40 degrees east or northeast 40 degrees. Um, Notice that your direction of an angle comes from your north-south line. So the direction comes from, where's my blue? So it starts here and then goes 40 degrees to the right because it's saying east. All right. Bearing. So another one. Let me draw it first. All right. So this one, north 65 degrees west. So that's 65 degrees. And it's going to the left from your north. All right, let me draw another one. All right. So the bearing from O to P is 7 degrees, is south 7 degrees east. So this time, starting with the south pole, and we go east, go to the right 70 degrees. All right. So questions on that terminology before we actually use it in a problem?
No.
All right. Sounds good. Let me write this out. All right. So a boat leaves the entrance to a harbor and travels 25 miles on a bearing of north 42 degrees east. The figure shows, which I will draw in a second, that the captain then turns the boat 90 degrees clockwise and travels 18 miles on a bearing of south 48 degrees east. At that time, how far is the boat from the harbor entrance? All right, so let's see if I can draw this. There we go. All right, so I think I'm okay now. I did the best I could. So, all right. So hold on. Let me draw. Make sure you see that that's arrow. That's the arrow, and it's the harbor entrance. All right. So let's go back to the description. Boat leaves the harbor, which is down here, bottom left corner. Travels up 25 miles. Well, it's bearing northeast, 42 degrees northeast. So, so that's what we're looking at. That's what we got is 42 degrees out here. Tells us we're going 25 degrees, 25 miles in that direction. Then the boat from this point right here turns 90 degrees clockwise. So that's where this 90 degrees come from. And it goes towards south 48 degrees east. Yep, going down 19. Okay. So the good thing about this one is that they gave us the diagram. Of course, if you're not efficient or proficient at these bearings, you may take you a little bit to actually draw this diagram on your own. But yep. So let's look at what they're asking of us. How far is the boat from the harbor entrance? So we want to know this distance right here. So since we have a 90-degree angle, gives us a right triangle, so we can use the Pythagorean theorem. A squared plus b squared equals c squared. And of course, a and b doesn't matter, they're interchangeable, but c is the one that's opposite of your 90 degrees. So that's the one we're looking for. So that'll stay what it is. We'll use the 25 and the 18. No, 25 squared is 625. But what is 18 squared? 324. All right, so solving using the Pythagorean theorem, taking the square root of both sides. After you've calculated 25 squared, which is 625, plus 18 squared, which is 324, square root of 949 will give you approximately 30.8 miles. So don't forget, whenever you take the square root of both sides, the square root property says that we will have a plus or minus result, but the negative result wouldn't be used in this case because there's no such thing as a negative measurement. So we would just use the positive, and that positive is the 30.8. All right. Questions. All right. So it says, what is the bearing of the boat from the harbor entrance? So in other words, when you go back to your diagram, if you were to take the boat and be at the harbor entrance, why is it not purple? And if you were to go this way, what is the bearing of the boat? So we know 42 degrees of it, and so we need to figure out what theta is so we can know the whole bearing. In other words, if I can get it out, we need to know all of this to know what the bearing of the boat is. So, well, let's find theta. We got opposite over hypotenuse. You want to do that? If we go off what I was saying before, normally you don't use what you calculated, you use what's given. So if we're going to use what's given in order to ensure that we're using the most accurate information, we would do opposite, which is 18, over adjacent, which is 25. All right, so tan theta is equal to 18 over 25. So we can use tan inverse to get theta alone. So theta will be approximately 35.8 degrees. So this means the bearing is going to be 42 degrees plus theta, 42 degrees plus that 35.8. which means it's going to be 77.8 degrees. And let me make sure I'm coming back down. Okay, there we go. So it's going to be north. So it'll be north 77.8 degrees east. All right. Any questions? Any questions?
No, sir.
All right, sounds good. So, with that being said, we are now done with chapter 5 lectures. What I'm going to do is, hopefully I can do it by tonight, but most definitely by tomorrow, create a test review so that you can look at, and then ask whatever questions you want to ask. So we need to set up a review day. Squeaky wheel gets the oil, so I'll let whoever want to speak say so. You can either say it in the chat or speak up, unmute yourself. Do you want your review day to be Thursday or the following Tuesday? Anybody? Nobody cares? Everybody good? So want me to make a decision?
I don't know. It's a tough decision.
So now, remember, this is not saying when you have to take the test. This is just saying, okay, see, Thursday, get it done and move on. Okay, sounds good. Say I'm cool for whatever. Okay, so this is just saying that this is the day I'm going to set aside. I'm not going to do anything new. I'm just going to answer whatever questions you have. So I see Thursday for the people who said something or gave an actual preference. They said Thursday, so we can set it for Thursday. So this Thursday, I will not do anything new. Hopefully I can create that review for you for the test and post it tonight so that if nothing else, let's say you don't get through all the homework, you'll at least be able to look at the review and say, okay, I want to see this type of problem done or this problem done because you couldn't figure it out. And that will streamline your study as far as what you need to know going into the test. Don't forget the test, you will take it on your own time. It's not like your homeworks. Whatever you get on the test is your score. And you get 2 shots to get the best grade possible. And make sure you shoot me the scratch work, whatever work it took for you in order to get the score on those tests. Make sure you send me a copy, take a picture of it, maybe scan it, whichever way is easiest for you. All right, any questions or concerns? All right, so if you guys are good, I'm good. I will see you on next class. Have a good one.
Thank you.
Thank you.